Hello kids, so this is the second video for the chapter motion. In the first video, we discussed on the topic motion, rest, quantity, unit, scalar quantity, vector quantity, distance, displacement. In this video, I'll be touching on the topic speed and velocity, and we'll look at few graphs. First, let's understand what is speed. A term we are very familiar. We say speed is change in distance with respect to time. Speed is the change in distance with respect to time. Or you could say speed is rate of change of distance. That is, we could write it mathematically as speed is change in distance with respect to time. Let's say you run 300 meters. 300 meters in 90 seconds, suppose. So what is your speed? Now 300 is the distance traveled. To travel 300 meters, the time that you took was 90 seconds. So your speed is 3 3s are 3 10s are 10 by 3 is 3.33 meters per second. That is, you are running at a speed of 3.33 meters every second. Now, what can be the unit of distance? If distance is measured in the units of meter and time is in seconds, speed can have the units meter per second. If distance is measured in the units of centimeter and time in second, it could be centimeter per second. If distance is measured in kilometer units and time is in hour unit, it could have the units kilometer per hour. We could have many other units. By changing different units of distance and different units of time, we can have several other units. The SI unit of speed is meter per second. Now, as speed is distance by time and distance does not take direction into consideration, so distance is a scalar quantity. Now, as speed is dependent on distance, speed is also a scalar quantity. Yes. Next, we can define instantaneous speed. The vehicle that you drive, it has a meter. We all are very familiar with this meter, right? There's a pointer. Here it would be 0, 20, 40. Let's say till here it's 160, and they would have written it in the units of kilometer per hour. So this reading shows us the speed. The reading through which we can know the speed, the meter through which we can know the speed, this meter is called as speedometer. The speedometer helps us to know the speed. Now, we have noticed that this pointer is never still. It keeps on moving. It either moves to the right, or if it comes to the left. If you increase the speed, the pointer will move towards the right. When you decrease the speed, the pointer moves towards the left. But the pointer indicates the speed at a very particular instant. That is, for a very small interval of time or a very short interval of time, when you are driving, for that particular instant at which you drive, at the speed at which you drive, the pointer will show that particular reading. So what is instantaneous speed? So we say instantaneous speed is the speed at a particular instant. When you drive at different speeds. If the traffic is clear, your speed would be more. If there is traffic, you will decrease your speed. But at any particular instant, the reading that the pointer is showing, the speedometer is showing, that speed is the speed for that very instant, for a very short interval of time. That speed is called as instantaneous speed. Instantaneous speed has the same unit as speed. Next is average speed. Now what is average speed? In instantaneous speed, we take a very short interval of time. For average speed, the time interval that we take is more. Let's say when you go from home to school. Let's say you are going on your Activa. When you go from home to school, you don't go at a constant speed. In between, the speed increases, speed decreases based on the traffic that we have. Now, let's say you went from home to school. The distance that you traveled was 5 kilometers. And the total time that you took to travel this 5 kilometers, let's say it was 10 minutes. So what is 5 kilometers over here? 5 kilometers is the total length between home to school. And 10 minutes is the total time that you took to reach school from home. Now, this is your total distance traveled and this is total time taken. The ratio of total distance to total time, we put mathematically average speed as total distance traveled by total time taken. Now what is the total distance? The total distance that you have traveled is 5 kilometers. What is the time? 10 minutes. Now because distance is in kilometer, with kilometer we normally prefer hour unit. To convert minute to hour, we divide it by 60. So now this is in kilometer and this is in hour. The 6 will go to the numerator, so it is 5 into 6 kilometer per hour. So your speed was 30 kilometer per hour. So now when we say 30 kilometer per hour, this speed is for the entire journey. So this speed for an entire journey or for a longer time interval, such a speed is called average speed. Now you would not be traveling at 30 km throughout this 5 km. There would be instances when your speed would be more than 30. And there would be instances when your speed would be less than 30. But what is this 30? It is the average speed. How do we find average speed? We say average speed is total distance traveled by total time taken. Yes? Just one more thing to add on. So we discussed that the meter that we have in the vehicle is a speedometer. But in the speedometer, there is one more reading. Yes? We have observed there are small numbers here.